So, number one, the divergence test. If the limit of the sequence is not 0, it diverges. So this says, is it possible for a series to converge if the corresponding sequence, that means this expression inside the series, diverges? No, not possible. Those, for it to have a chance at converging, a sub k has to go to 0 for it to have a chance. And just because a sub k goes to 0 does not mean it converges, okay? But for it to have a chance to converge, it has to go to 0. So if a sub k diverges, there's no way this can converge. So the answer is no there. All right, number two. So we have the same degree, top and bottom. So it's the ratio of the leading coefficients, 3/7. That's it. That's all you had to do. Number three. So R is 2/5. A is 1. Remember, A is the first term. So when we put in 0 for K, A is not what we get when we put 1 in for K. It's whatever the first term is. So it's whatever that gives us at the start. And anything to the 0 is 1. So A is 1. R is 2/5. So it's A over 1 minus R. 1 over 1 minus 2/5. Simplify, we get 5/3. So 23 points possible on that page. Those that did the makeup exam, same problems, different numbers. Okay? All right, number 4. Determine whether this series converges or diverges. Well, this is the divergence test. The limit of that expression, so the limit of the sequence, is 1/2. If that is not 0, it diverges by the divergence test. If that were to be 0, that test would be inconclusive and we would have to do something. Okay. All right, number 5. So, a lot of you did a bunch of crazy stuff here, and it's not hard. So what we needed to do is start putting in numbers and generate a series. So we put in 1 for K, 1 plus 1 is 1, so 1/2, that's that 1/2 there. And then 1 here, 1 plus 2 is 3, that's minus the 1/3. Then put in 2 for K and you get these, 3, and so on. Then put in for K. You get n plus 1 in the denominator on the first one, n plus 2 on the second one. Then we see that the last term here cancels with the first term in there. The last term in there cancels with the first one in there. And that pattern is going to continue and cancel everything in between, including the first term here. N is where we stop. This is not infinite yet. Then, whatever didn't cancel is what S of n is equal to. So if you want to know the sum of the first 10 terms, put in 10 for n right here, work this out, and you got it. Okay? If you want to know the sum of the first 1,000 terms, put in 1,000 for n, and you got the sum of the first 1,000 right there. Now, the sum, S, without the n there, indicates the infinite sum. So it says, then evaluate the limit of S of n, that would be this big S, to obtain the value of this series or state that the series diverges. Well, this piece is going to go to 0, so this is going to equal 1/2. If we carry this out infinitely, the sum will be 1/2. So again, a lot of you did lots of crazy things there, and you made it harder than it is. Okay, these are 10 points each, by the way, so 20 points on that last page. Number 6, show by comparison test. So I really need to see this statement. You need to show me that this is less, so wait, back up. We see a k to the third in the bottom. So by p-series, we suspect, our hunch, our educated guess, is that this is going to converge. Okay? That's our educated guess. Now we can't apply p-series to this because of the plus 1. If the plus 1 was not there, then we could use p-series. So that's why we need the comparison test. Well, we suspect that this converges. So we need to find a series to compare it to that we know converges and that we know this is less than. Doesn't work if this is greater than. We're going to find one that we know converges and one that this given series here is less than. So 1 over k cubed is easy because if you add 1 to the denominator, that makes this less when you have a bigger denominator. So we know that this is less than 1 over k cubed for k greater than or equal to 1, where that's starting. We know that this converges by p-series. That implies that our given series converges by comparison. Okay? Do you see the logic in these statements? You need to understand that logic. All right, number 7. Show by the ratio test. So we put the k plus 1 term on top, the k term on the bottom. Absolute value. Absolute value is not necessary because these will always be positive, so I leave it off here. And I multiply by the reciprocal. Then I rearrange. Not a required step, but I did it so you can see it. I just rearrange so that the 2 to the powers are with each other and the factorials are with each other. Subtract k minus 1 minus k, and we get 1. So that's 2 to the 1. K factorial cancels out from k down on the bottom, leaves us with k plus 1. This equals 0. Converges by the ratio test. Good there? Okay, number 8. Use the root test. All right, so we put this expression. I left out the -1 because of the absolute value, just to make it a little cleaner. Technically, it could have been put in, but absolute value takes it out. So there it is. The kth root cancels that k exponent. We end up with that expression. The numerator and denominator of the same degree. So that equals 3/2, the ratio of the leading coefficient. That is greater than 1. I probably should have wrote that there. So it diverges by the ratio test. 3/2 is like 1.5. Okay, look what we all have in this question here, or this task. We have to determine if it converges absolutely, conditionally, or diverges. Well, the limit of this expression is 0 as k goes to infinity. That is the alternating series test doing that limit. So we know it converges by alternating series test. But now we need to test for absolute convergence. Well, this equals 1 over k, which diverges by p-series. That's the harmonic series. So it only converges in alternating form. That means it converges conditionally. Converges on the condition that it is alternating. That make sense? And what we have here is we have the alternating harmonic series. All right, that's alternating harmonic series. And it converges in alternating form, diverges in absolute form. That's number 9. That's it. So it's out of 83 points. Those of you that came and made it up in my office, the problems were similar, but different numbers. If you want to look at that key, you can come look at it after class, whoever took that one. All right. If you haven't taken it yet, I have to make a completely new